Algebra 2, Lesson 5-2. Polynomials, linear factors, and zero. A multiple zero is the same repeated linear factor. For example, if I said x equals 2 and x equals 2, that would be a repeated factor for x equaling 2, so that would be a multiple zero. Multiplicity is the number of times the repeated linear factor is repeated in the factored form of a polynomial. For example, if I had a polynomial and it was factored to x plus 2 times x minus 2 times x plus 2 times x minus 7, then x plus 2 is a repeated linear factor where x is equal to negative 2. So negative 2 would be a multiple zero, and its multiplicity would be 2 because it appears twice. A relative maximum is the value of the polynomial function at an up to down turning point, and a relative minimum is the value of a polynomial function at a down to up turning point. And I'll show you pictures of those in a little bit. Now, finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the related polynomial equation. When we were in Chapter 4, we solved the quadratic equation of the form by factoring. You wrote it using linear factors in the form of, oh, I forgot to write this down there. If you had it, this would be in the form of x squared plus bx plus c equals 0. And you factored those. And you basically factored them in the form of like x minus r to the sub 1 times x minus r sub 2, or x plus r sub 1, x plus r sub 2. Then we use the zero product property to find the solutions. We can solve some polynomial equations in much the same way. Okay, not all, but many of them can be. Okay, for example, let's take a look at the following. We're going to write a polynomial in factored form. If I have x to the third plus x squared minus 12x, the first thing you always look for, greatest common factor. My GCF here is x. So if I take out an x first, I will get x squared plus x minus 12. Now I need the product of negative 12 and the sum of positive 1. That would be positive 4 and negative 3, because positive 4 times negative 3 equals negative 12, and positive 4 minus 3 equals positive 1. So I have x parentheses x plus 4 and parentheses x minus 3 equals 0. Okay? So we've written it in, basically in factored form would be this right here, not the equals 0 part. So that's it in factored form. If we looked at 3x to the third minus 3x squared minus 36x, again look for your greatest common factor, which in this case is 3x. So I can take a 3x out of everything. If I do that, I'm left with x squared minus x minus 12. Very similar to the first problem, this trinomial part. I need a product of negative 12 and a sum of negative 1 this time. So that's going to be negative 4 and positive 3. So we will have 3x parentheses x minus 4 parentheses x plus 3. And that's the polynomial in factored form. Again, you have to learn how to factor. We've done factoring in Algebra 1, we've done factoring in Algebra 2. You are going to use factoring forever, so you might as well get it down now and get less frustrated later. All right. Roots, zeros, and x-intercepts. The following are equivalent statements about a real number b and a polynomial function that's written as p of x equals a to the n, x to the n, plus a to the n minus 1, x to the n minus 1. In other words, a to the n means like 3x, and then you're going to go down. This variable goes down, this variable goes, the exponent goes down, just to put it in standard form. It's the way they write it as in standard form. If x minus b is a linear factor of the polynomial, okay, this is what you do know. X minus b is a linear factor of the polynomial p of x. B is a zero of the polynomial function y equals p of x. B is a root or solution of the polynomial equation p of x equals 0, and b is an x-intercept of the graph y equals p of x. Basically, all four of these things mean the same thing. If you find a linear factor, it is also a 0. If you find a 0, it's also a root. If you find a root, it's also the x-intercept. They're synonymous terms. You need to be familiar with the fact that they use them interchangeably all the time. So you need to know that if they ask you for a linear factor, that's also asking you for a 0, it's also asking you for a root, and it's also asking you for the x-intercept. Now, we're going to find the zeros of a polynomial function. what are the zeros of the polynomial function y equals x minus 3 parentheses x plus 4 parentheses x minus 1. And then we're going to graph the function. Luckily for us, they already put it in factored form. We don't have to factor it, which makes it really, really quite simple. We're just going to use the zero product property to find all the zeros, which means x minus 3 equals 0, x plus 4 equals 0, x minus 1 equals 0. So in other words, x can equal 3, negative 4, and positive 1. So our zeros are at 3, negative 4, and positive 1. Now we're going to find points for x values between our zeros. Okay, so we should pick a point somewhere between negative 4 and 1, and then we should pick a point between 1 and 3, okay, at least, if not one or two of them. Okay, so I'm going to pick some points between there. So between negative 4 and 1, I'm going to choose let x equal negative 2. I'm going to let x equal 0, because that's between them. And between 1 and 3, I'm going to let x equal positive 2. So now, we're going to plug those numbers in to the equation of x minus 3 parentheses x plus 4 parentheses x minus 1. So y will equal, okay, remember this is the formula, we're using this quadratic function, x minus 3 parentheses x plus 4 parentheses x minus 1. So now I'm going to plug in negative 2 for x, so y is going to equal negative 2 minus 3 times negative 2 plus 4 times negative 2 minus 1. Okay? Negative 2 minus 3 is negative 5, and that's going to be multiplied by negative 2 plus 4 is 2, and that's going to be multiplied by negative 2 minus 1 is negative 3. Okay, so it ends up to be a positive number. 5 times 2 is 10, times 3 is 30. Okay, so negative 2, positive 30 is another coordinate point. Okay, so I'm going to do the same thing now with x equaling 0. So I'm going to have 0 minus 3 times 0 plus 4 times 0 minus 1, which happens to be negative 3 times 4 times negative 1, which happens to be 12. So my next point is going to be at the point 0, 12. And then my last point, which is 2, I'm going to have 2 minus 3 times 2 plus 4 times 2 minus 1. 2 minus 3 is negative 1. 2 plus 4 is 6. 2 minus 1 is 1. So that's going to equal negative 6. So my last point is at 2, negative 6. So there's all the points that I need to graph on my lovely graph. Okay, so I'm just going to draw an x and y axis. There's my x-axis. That's a terrible y-axis, but it's close. It was better when I actually drew them. I'm going to draw them in with the... This works much better. X-axis, y-axis, because I can move this if I need to, because if I get it off like I just did, I can move it over to where it's supposed to be. Right there. There we go. So there's my x and y-axis. Alright, so x, y. So I'm going to plot the points where there are zeros. Okay, remember, if it's a 0, that means y is 0. X is negative 2. So these 3 points here are zeros. It's where it crosses the x-axis. Crosses the x-axis at negative 2, which is this point right here. Crosses the x-axis at, excuse me, crosses the x-axis here. Yeah, I messed that up, didn't I? I'm looking at the wrong thing. So it crosses the x-axis at 3, so we'll plot that point. It crosses the x-axis at negative 4. 1, 2, 3, 4. And it crosses the x-axis at 1. Okay? And if we only did those, it looks like a straight line. That's why we have to have these other points. Okay? So our other point is negative 230. That is not going to fit on my graph. 0, 12 probably will. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Haha, barely. But it fits. And then 2, negative 6. 1, 2, 3, 4, 5, 6. I can probably plot that fairly reasonably. So now I need to draw my graph. Okay? But before I do that, I should probably figure out my end behavior. So my end behavior is to the third power. Okay, third degree. So it's odd, okay, and a is greater than 0. So it's odd with a greater than 0, so it means it goes down then up. Okay, so I should have a point where it's going to be going, okay, I'm going to have a nice little curve here, and it's going to somewhat match here, and then it's going to go down here. I missed that point. I missed both of those points. That is terrible. So it's going to go, there we go, and then it's going to come back up this way. So there's what my graph somewhat looks like. That's a sketch of my graph. I didn't do the most spectacular job, but it's close. Okay. And of course I should label it y equals x minus 3 times x plus 4 times x minus 1. And that didn't fit very well, but there it is. There we have our graph. It's a sketch. It's not perfect. Then you can put that on your graphing calculator to determine if you're close. And you'll find out that you're fairly reasonable for a graph. That's how you would graph a polynomial function. Okay, finding its zeros and then graphing it by hand, which is a very important skill to be able to do because you know me, I'm going to stick that on your tests without the graphing calculator. The factor theorem describes the relationship between the linear factors of a polynomial and the zeros of a polynomial. The factor theorem basically says this: the expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. Okay? So in other words, x minus a is a factor as long as a is a zero. Okay? So writing a polynomial function from its zeros. Write a polynomial function in standard form with the given zeros. Then I'm going to get the zeros. You've got 5, negative 1, 3. So if these are zeros, what that essentially means is, that means x equals 5, x equals negative 1, and x equals 3, which means x minus 5, because you have to put it back in, so you have to subtract it to the other side, x plus 1, that would be this one, and x minus 3. Okay, that equals 0. So to find this in standard form, we have to multiply all these together. Now you can't multiply them all together all at once. You have to multiply any two and then multiply that answer by the third one. And it doesn't really matter. Multiplication is commutative. Order does not matter. So if I multiply these two together, I will get x squared plus x minus 5x minus 5. You should be able to do that pretty much in your head by this stage of the game. It's first term times everything in the second term times everything in the second polynomial. So if you can't remember how to do that, that was x parentheses x plus 1 minus 5 parentheses x plus 1. And you would have gotten x squared plus x minus 5x minus 5, which simplifies to x squared minus 4x minus 5. And now we're going to multiply that by x minus 3. So I'm going to take x, because I'm going to take this one and I'm going to multiply it by the longer one, multiply it by x squared minus 4x minus 5. Then I'm going to take negative 3 and multiply it by x squared minus 4x minus 5. If I distribute, I'll get x to the third minus 4x squared minus 5x minus 3x squared plus 12x, watch signs, plus 15. Now simplify and write it in standard form. There's only one x to the third, so that's gone. Negative 4 and negative 3 is negative 7x squared. Okay. Negative 5x, positive 12x is positive 7x. And plus 15. So this would be f of x equals x to the third minus 7x squared plus 7x plus 15. Now, if you have the TI Inspire, it has a nifty little feature to it that the 84 does not have. And you can actually multiply using the TI Inspire. Do remember, I'm going to make you do this by hand, so having the TI Inspire is just a great way to check your answers, to make sure you're checking them properly. You'll just go to Menu, you'll go down to Algebra, and you'll go to Expand, which is number 3, and then you'll just type in x minus 5, parentheses, x minus 5, parentheses, x plus 1, x plus 1, see x minus 3, and it'll multiply it all together and give you x cubed minus 7x squared plus 7x plus 15. And then you can double check and make sure your answers are right. So it's kind of a neat feature, and it makes it quite simple to be able to multiply if you're not really good at multiplying. Let's take a look at another one. This one has 4 zeros, okay, which means more multiplication, obviously. Okay, we have x equals 2, x equals 3, x equals negative 3, x equals negative 1. So we have x minus 2 times x minus 3 times x plus 3 times x plus 1. Personally, I'm going to multiply these two together, and then I'm going to multiply these two together, because I know x plus 3 times x minus 3 is x squared minus 9, because my middle terms cancel out. So I have x squared minus 9 for the first one. And if I multiply x minus 2 times x plus 1, I will get, let's see here, I get x squared plus x minus 2x minus 2, which is x squared minus x minus 2. So now I need to multiply those two polynomials together. So I'm just going to take my x squared and multiply it by everything in the second polynomial, x squared minus x minus 2. And I'm going to take my negative 9 and multiply it by x squared minus x minus 2. So when I multiply, I get x to the 4th minus x to the 3rd minus 2x squared minus 9x squared plus 9x plus 18. Now I'm going to simplify. Notice the better you are at multiplying, the faster these will be. I get x to the 4th minus x to the 3rd minus 11x squared plus 9x plus 18. I think that's right. X to the 4th minus x to the 3rd minus 2x squared minus 9x squared plus 9x plus 18. Yup. So you end up getting, when you multiply this out, I think, I'll make sure I did this right. That would be x squared plus x minus 2x minus 2, so it's going to be minus x, yep. So when you multiply all that out, you get, that's the standard form of it, so I just put f of x in front of that, equals that, and you have the standard form of that equation. And you can check it on your calculator if you have the TI square. Okay. That is finding a polynomial function from its zeros. Now we're going to look at multiple zeros. How do multiple zeros affect a graph? If a is a zero of multiplicity n in the polynomial function y equals p of x, then the behavior of the graph at the x-intercept will be close to linear if n equals 1, close to quadratic if n equals 2, and close to cubic if n equals 3. Okay, so in other words, if you have a multiplicity of just 1, it's going to be closer to linear. If you have a multiplicity of 2, it's going to be closer to quadratic. If you have a multiplicity of 3, it's going to be closer to cubic. So we're going to find the multiplicity of a 0. What are the zeros of f of x equals x cubed minus 5x squared plus 3x plus 9? You don't know how to factor this. You don't know how to use polynomial long division yet on how to factor this. So we're going to use our graphing calculator for this particular problem. So we're going to put this in our graphing calculator. Okay. So if I put this graph in my graphing calculator, and then I'm going to sketch it, and then we'll analyze it from there. So I'm going to add this graph to my calculator. So I have x to the 3rd minus 5x squared plus 3x plus 9. If I graph that, okay, it looks like I have a graph that looks a little bit like this. Okay, I'm just gonna show you off to the side. My graph looks like it goes like this. Okay, something like that. What I want to do is I want to find my zeros first, okay, so that I can sort of graph it a little bit better. I mean, it doesn't really matter. We're just sketching a graph, just so that we can kind of see what it's doing. Okay, So I have a graph that looks like it's coming up like this, and then coming down like this, and going up like this, and then coming up like that. That's kind of what my graph looks like it's doing, right? And with my calculator. So if I look at that, it looks like, if we look at it, we have two places it crosses the x-axis, here and here. Here, the left-hand one, it crosses the x-axis. The right-hand one point, it actually just touches the x-axis and comes back up, which leads me to believe that that is a multiple zero, because it is. Okay? So this point here is a multiple zero, and that's the point 3. So 3 is one of the zeros, and it has a multiplicity of 2. Since the graph only touches the x-axis. And then turns around. My other zero is at -1 with a multiplicity of 1. Since it intersects or crosses the x-axis. So there we go. So we have 3 zeros. Right? We can have at most 3 zeros, because you can only have as many zeros as you have your greatest degree. We have 3 zeros. 3 has a multiplicity of 2. And -1 has a multiplicity of 1. So that makes our 3 zeros. Okay. If the graph of a polynomial function has several turning points, the function can have what we call a relative maximum and a relative minimum. A relative maximum is the value of the function at an up to down turning point. See, notice this is going up and then going back down. A relative minimum is a value of a function at a down to up, down and then up. Okay? So relative maximum, relative minimum. It's not the maximum minimum, because obviously the graph's continuing on this direction, and it's continuing on this direction. So down here, way down here would be a minimum, and way up here would be a maximum. But if it goes forever to infinity, you're never going to have an exact maximum or an exact minimum. So we can have relative maximums and minimums. Okay, so what are the relative maximums and minimums of the graph of f of x equals 3x cubed plus x squared minus 5x. We're going to use the graphing calculator to find those. So we're simply going to put this graph in the graphing calculator. Okay, so we're just going to put this new graph in 3x to the third plus x squared minus 5x. Let's graph it. And we can see that my graph looks sort of like this. I'm just going to sketch it off to the side. It looks something like that. Okay. So this would be a relative maximum, and this would be a relative minimum. To find those points, you're simply going to just use the maximum and minimum in your analyzed graph. Okay. So I'm going to do my maximum first, because that's on the left-hand side, and I'm going to scroll over and try to find my maximum point. So go a little bit to the left of the relative maximum and a little bit to the right of the relative maximum. And you will find a relative maximum is at -0.865 and 3.13. Okay. So my relative max is at -0.865, comma 3.13. And my relative minimum, I'm going to find it the same way, except for now I'm going to analyze my graph and look for the minimum. Okay, so I'm going to choose a minimum. I'm going to go to the left of where I think that minimum point is, and to the right of where I think that minimum point is. Okay, and I find that it is at 6.42, -2. So those are my maximum and relative minimum as done with the graph on the graphing calculator. Would be really hard to do without a graphing calculator, so hopefully you have your graphing calculator. Last but not least, we're going to use a polynomial function to maximize volume. It's a word problem, everyday type of problem. In other words, what in the world are we doing and how does it apply to real life? Here's an example of how it applies to real life. Several popular models of carry-on luggage have a depth of 10 inches greater, a length 10 inches greater than their depth. To comply with airline regulations, the sum of the length plus the width plus the depth cannot exceed 40 inches. Assume that the sum of the length, width, and depth is exactly 40 inches. We're going to graph a function relating volume V to depth x. Find the x-intercepts and what do they represent. So the first thing we're going to do is we have to define some variables. We have to define a lot of things, actually. We know, hopefully you know, that the volume of anything, when it comes to luggage, is rectangular. So it's a rectangular prism. The volume of a rectangular prism is depth times length times width, or length times width times height, however you want to define it. Right? But they give us a depth, and it says I'm going to let x equal my depth, because everything is compared to the depth. Because it says the length is 10 inches greater than my depth. So x plus 10 then is going to have to equal my length, isn't it? And we know that to comply with airline regulations, the sum of the length, the width, and the depth cannot equal 40. So 40 minus my depth plus my length has to equal my width. So let's think about that for a minute. So 40 minus my depth, which is x, plus my length, which is x plus 10, equals my width. And I can simplify that even further. Okay, if I run the negative through, I'm going to have 40 minus 2x minus 10. So 30 minus 2x happens to be my width. Okay, so now I have my depth, my length, and my width, and we know that volume equals depth times length times width. So the volume in terms of x, V of x, is going to equal my depth, which is x, times my length, which is x plus 10, times my width, which is 30 minus 2x. So that is the volume of this function. I'm going to graph this function in my calculator, and I'm going to put it in just like that on my graphing calculator. I believe you can do it in both forms. I'm just going to use my Inspire. I know you can put it in just like that in my Inspire, because all I'm going to do is plug it in exactly as we see it. Okay, so I'm going to put in parentheses x, parentheses x plus 10, parentheses 30 minus 2x. Graph that. Okay, and when I do that, I see pretty much nothing on my screen, which means I really have to play with my window a little bit. Okay, and you can do that by going to Windows Zoom, and I'm actually going to do my window settings. I'm not going to hit Zoom Fit or anything else like that. I'm going to get to my window settings. You could do it by Zoom Fit, I think, maybe. I'll try Zoom Fit first. That works. So once I hit Zoom Fit, I get a nice little graph. Okay. I need to figure out where my intercepts are, and it looks like my intercepts, I already know where my intercepts are. I should have an x-intercepts at x equals 0, x equals negative 10, and when you solve this equation here, you get x equals 15. Okay. Now, realistically speaking, since this x is my depth, I can't have a piece of luggage that has no depth at all. I can't have a piece of luggage that has a negative 10-inch depth. So I know my piece of luggage has to have a depth between greater than 0 but less than 15. So I know now that x has got to be greater than 0 but less than 15, because I can't have a negative depth, and if I have 0 as a depth, I don't have a piece of luggage. I have like a piece of paper. Okay, it's not going to hold much. So once I know that, okay, so we know that the depth of the luggage must be a positive, so the depth's got to be between 0 and 15. We are going to now look at we want to find the maximum possible volume of a piece of luggage where the depth is between 0 and 15. We want to look for the greatest value of y that occurs between x being 0 and 15. So we're going to go back to our graph at this point in time, and we're going to use the maximum on our graphing calculator, and we're going to go to the right of the y-axis because nothing to the left of the y-axis is going to work because that gives us as x is less than 0. So I'm going to go and find my maximum. So I'm going to do my analyze graph, and I'm going to find my maximum, and I'm going to scroll over, and I'm going to find my maximum is at 8.93, and it says 2.05 times 10 to the third. Okay, so when I do that on my graphing calculator, I get 8.93, comma, 2.05 e to the plus 3. Okay, so this is the depth of my suitcase, and this is the volume. This would be depth, and this is volume. That's what those things mean. It says find the x-intercepts. What do they mean? What do they represent? We found the x-intercepts represented where my depth could be, but my depth can't be a negative number or 0. So now that we know that a volume of approximately, okay, so my volume of approximately 2050 cubic inches, because that's what you do when you get this out of scientific notation. Okay. So I have a volume of approximately 2,050 cubic inches occurs when my depth, okay, at a depth of about, and I'm just going to round it to 8.9 inches. So if my depth is 8.9 inches, I can find all my other dimensions. Okay? If x equals 8.9 inches, x plus 10 will equal 18.9 inches, and then 30 minus 2x, okay, is going to equal 12.2 inches. Okay, so my depth is 8.9 inches, my length is 18.9 inches, and my width is 12.2 inches. So I found the dimensions of my suitcase and the largest volume that will fit under the ramifications that the airlines gave me. These are just some of the things that we can do with polynomial functions, especially looking at their zeros.